Hey guys, this is Quads here, just finished freshman year of college. I'm going to be doing the limits definition of derivative worksheet. So, this one requires a bit of an introduction. So first of all, the derivative is by definition the slope of a tangent line. So it's basically the slope of a function at exactly one point. So if you can imagine a function you choose a point on it and you would draw the tangent line to that point and it's the slope of that tangent line. So there are two main definitions of these derivatives that are equivalent. So I'll be writing those here in a second. Both of them are correct definitions of the derivative, and you're probably going to have to deal with both of them an equal amount in your calculus journey. But in order to distinguish them, I'm going to call one the h way. That's the one I'm writing right now, because this limit is h to 0. And that's supposed to be an h down there. I know it looks like an m. I don't really know what I was doing. H way. That's an h. The other option, I'm just going to call the non-h way. So I'll be writing that now. The non-h way is a little easier to understand, why it is the way it is. So the limit is just slope. If you look at it here, it's y minus y over x minus x. And so remember, the a is the point on the function. So the a would then be the x coordinate, and the f of a would be the y coordinate for that point. So this x is approaching a, so it's getting really close to a, and that's how it becomes the slope of the tangent line at point A. H way is also slope, a little more complicated to understand. Also, remember that derivatives are limits. They're a really special kind of limit. So not every limit is a derivative, but every derivative is a special kind of limit. And so our goal in this worksheet is not to actually compute limits, but we're gonna turn them into derivatives because all of these are the special kind of limits that are derivatives. That these limits define a derivative the way these forms are the definition of a derivative. So if you find a limit in these special forms, you can just turn it into a derivative and then solve it as the derivative, which is much easier than doing all that algebraic manipulation that a lot of limits have. And you cannot use this method for every limit you see. Only the ones that fit these formats that are the actual definition of a derivative can be turned into a derivative, because the other ones, if they don't fit the definition, then they're not a derivative. So you can't solve it that way. So this is just how you define what a derivative is. It's how you know if you can use it. Also, so if we're looking at this non-h way, the top left corner, you're going to see that f of x, that function. A is going to be right here. You can find it because x is approaching a. You can also look for it in this bottom right corner. You won't be able to see it in this f of a because that's going to be the computed value of f of a. You'll see that when we do the example. So yeah, just look down here or here. The h way is a little bit trickier. So the way I identify these is that whatever is being added to h is the a, and then you take that thing, that a plus h, so imagine it it's parentheses here, that one object a plus h, and then whatever that's being plugged into is the function, and you just replace it with x. So if it was 5 plus h to the 5th, then the 5 would be a, and then x to the 5th would be the function. And so that's important to know where to find f of x and a, because, oh, you can't see it, my face is in the way. As you see down here, we've got a couple steps to be able to figure out, or to be able to solve these problems. And the first thing you need to do is identify the function and the point, which is a. So remember, a is the point at which we're finding the slope of the tangent line. For the h way, like I said, a is something plus h. So let's see if you can see this a little better here. And then after you identify that a and that h, that's when you're going to actually take the derivative and plug in a. So you're basically taking f prime of a, because you're taking the derivative of f of x, that's f prime of x, and then you're plugging in a. Because you want the slope at point A. You want, the slope is f prime of x. It's the slope of the function at any given point. You want it at point A. And so you're just plugging in A. So we are going to get started over here with number 2. First thing, this is the function f of x, top left corner, like I said. You can tell it's a function because it's something like being done to x, and like, you know what function is. And then we're looking for a, which is here and here. You can find it in both spots, so a is a. And then, sorry, I don't know about you guys, but during quarantine, people yell across my house. I had to pause for a second. Here's a cool thing you can do to check that you got the right numbers or things for a and f of x. We took this 2 here and we just plugged in f of 2, because remember, this should be f of a. And if f of, f of 8 should equal, 2. So I think I wrote that wrong. Yeah. So it would be f of 8, you plug 8 into f of x, and you get 2. So we're going to start actually getting the derivative here. So first we're going to rearrange this so we can do power rule. So now we got f prime of x equals, f prime of 8 equals 1/3 x to the negative 2/3. And then x equals 8. Okay, so we're going to plug in 8. Sorry, this is super messy. I didn't really plan this well with where I wrote the steps, and so we're kind of getting all discombobulated, but just bear with me. Go ahead and plug in the 8 into this. Remember that the cube root of 8 squared is the same as 8 to the negative 2/3, and you get 1/12. The next one is the h way. Can you see that? There we go, h way. So the first thing we're looking for is a, whatever's being added to h. So you know a is 2, and then what is that whole thing? Like, what is it being plugged into? What's the function? It's that whole thing to the 6th, so then the function is x to the 6th. And then after that, we just do the same steps for both of the ways. F prime of x next, or f prime of 6. I keep doing that. I guess you just automatically stick it in there. You know what? I just really can't speak today. It is f prime of 2 because a is 2. I had the 6 in my head from this, but ignore me. F prime of 2. Go ahead and do the derivative with the power rule, plug in your 2, and you should get 192. I just like my boxes to be like really thick, so sorry. Number 4. Let's see. This one, I want to go ahead and remind y'all of the a to the x derivative rule. Well, first we'll find the f of x and the a. That is the first step. So f of x, 2 to the x, and then a here is 5. You can see it right there, right there. Can you? There we go. And yeah, since our function is 2 to the x, that's like an a to the x style. I know that's confusing with all the a's, but if you think back to like the power rule video, if you watch that, we also included the like a to the x rule. and so that's not the same a as this a. That is a different a. But the derivative of a to the x is a to the x ln a. So 2 to the x is our like a to the x function. So when we take that derivative f prime of 5, go ahead and plug in that a. It's 2 to the x ln 2, and then you plug in 5, and you get 32 ln 2 after you do some simplification. I don't know if you guys ever played that 2038 app, but that's 2048. What am I saying? That is how I learned my powers of 2. How I remember them. So here we go with another h-way. Oh, one moment. Okay, so technical difficulties. Missed me writing this part. Basically, you just found a is what's being added to h, f of x, the whole thing to the 10th. So now we're taking f prime of 1. It's an easy one, power rule, plug in your 1. Also easy, we love 1 to the 9th. Answer is just 10. Nice and simple. Number 6 is another non-h way. So a you can spot right there, right there. That's just a coincidence that a is also up there. These two are your spots to look for it. And here's your f of x. And we go ahead and take that derivative. Another easy power rule. Plug in that 1. 999th degree is easy when you're doing 1 to the 999th degree. And we just get 1,000. That's a really ugly box around my 1,000. I'm sorry. This one, we get to do trig. I'm not a fan of trig. Maybe you are. That's awesome. So our a, pi over 4, pi over 4. F of x is tan x, that's a function. Here's a little thing we want to do just to get, if you remember your like coordinate plane with your angles. Pi over 4 is there. Our point is here. Root 2 over 2, root 2 over 2. So now we're going to take the derivative. The derivative of tan x is secant squared x. Those you just got to memorize. Love it. Go ahead and plug in that pi over 4. And it's easier to then convert that into 1 over cosine squared pi over 4. And then we get 1 over root 2 over 2 using this coordinate we've been given. Yeah, and the answer to that, oh, I don't know if you can see this. There we go. Is 2. That took a couple equal signs. Next one, let's see, what do we got? We got another h way. 16 is what's being added to h, so that's your a, right here. And then that whole thing, it's 4 root that. So 4 root x, which we can, or the 4th root of x, which we can turn into x to the 1/4. Remember, you want to convert that because it's easier to take the derivative. 1/4 x to the negative 3/4, and then you plug in x equals 16. And then you just convert that x to the negative 3/4. That's same thing as the 4th root of 16 to the 3rd on the bottom of the fraction for the negative, and you get 1/32. That's just mostly a practice at rearranging. Oh, this next one's fun. So notice here we have t to the 1st. So this whole thing is our f of x to the 4th plus t. This is a non-h way. But just instead of x to the a, it's t to the a. Same thing. So a is 1, you see it here, see it here. F of t is t to the 4th plus t. We're looking at the t right there, so we got a t down here. So f prime of 1, 4t to the 3rd. That's a 4. I know it looks kind of like a 9. It's a 4. 4t to the 3rd plus 1. And then you just plug in that t equals 1. It's my face in the way again. And you get 5. So it's pretty simple once you realize that this whole thing is the function and you realize that it is the non-h way. It's just using t. So next we have an h way again. A here is 2. Oh, my hand's in the way. 2 is being added to h. And that whole thing is being plugged into the function ln of this, ln of x. So we're going to go ahead and take that derivative. It's just 1 over x. Plug in your 2. And you get 1/2. It's a good one. Nice and simple, if you remember the derivative of ln x. This one we want to rearrange that f of x. So first, we have our 4 here. Our f of x is here. This is just an x way. I know there's like a subtraction in there, but it's x to the something, so it's the non-h way. And also, side note, I realize now up here with the t's, sorry, we call it the non-h way instead of calling it the x way, because like you could do it with a t. But yes, okay. So we're going to rearrange this into x minus 3 to the 1/2. Take the derivative, plug it in. You know the drill at this point. And you get a nice 1/2 again. Oh, 1/2 to the, so it ends up still being 1/2. Forgot that little part. Number 12, we have another h way. This one's a little funky. So our a is what's being added to h, if you can see it there. 5 plus h, still the a. And the function is this thing, so it's 1 over x. Even though there's something else on top, even though it looks intimidating, it's pretty simple still. Remember that 1 over the x is the same as x to the -1. And then if you do the power rule, that's how we got this as the derivative. Then you just plug in your 5. You get -1 over 5 squared equals -1/25. This is an h way. I was being dumb and looked at the wrong part of my notes. So ignore this. I'll cross it out here in a second once I realize my mistake. This is an h way. I'm just going to add that little plus 0 because that's what it means. H is the same thing as h plus 0, and that's how we know that that's our a. These a is whatever's being added to h. So you just kind of like manually write that in to help you like process it. And then we have our function here is 5 to the x. That's another of the a to the x rule ones. Remember, don't do power rule for that. It would not turn out happy. So yeah, you get 5 to the x ln 5. Plug in that 0. 5 to the 0 is just 1. So your answer is just ln 5. I'm gonna have to move again. There's just like not a good place for my face. This one is the one that's not actually the h way, even though it has an h. I know, it's weird. It's a trick question. It's h to a. So if it's the h way, it's gonna be h to 0. It's like part of how the h way works. And h is basically just being put in for x. The way it would be x to a, t to the a, like we had earlier. If I can go all the way up, you can't see my dotted line, but I drew a really pretty dotted line. Because over here it's the same thing as t to the 1. It's just h to the something. And this one just kept a. It didn't put in an actual number, so you're just going to have a in your answer. It's just a constant. But it could have been, if it was h to 5, it would be the non-h way, the same thing. It's only the h way if it's h, the limit of h approaching 0. So a is just a, and because there was no number, they just left it as a, which you can tell because it's here and here. And then we're using h, so f of h is 1 over h, and then f prime of a. And that's negative h to the negative 2, because again, like we did up here, it's just h to the negative 1. There you go. That was a tricky one. This one's pretty straightforward. A is 3. This time, this whole thing is our function. Again, don't be thrown off by the fact that there's like subtraction in here. Doesn't make it the h way. It would have to be h to the 0 and then something plus h with h on the bottom for the h way. So this one's pretty clearly not the h way. That's just the whole function. And you keep the 5 minus the x because it's already in function form. The h way is the time where you replace that subtraction with, or the addition with x, but this is not that. So yeah, that's the whole function right there. And then you take it, you get this negative from the chain rule, because of that minus x. Plug in your 3. Yeah. So for this one, we got a is 5 here and here. Here's your function. Again, it's the non-h way, so you just take that function, plop it down, take the derivative. Again, we got this negative from the chain rule, hidden up here. Plug in your 5. And then we're going to turn this negative exponent back into fraction form. In a second we are, after we plug in the 5. And there we go. We get pi, negative pi for this negative, and then that whole thing becomes that negative, the bottom half of the fraction. Number 17. Okay, here we go. We got a equals 4, 4. And you got your ln x squared as your function. Again, chain rule comes in here for this 2x on top. Sorry, my handwriting's a little unclear here. My hand's kind of in the way. Yeah, there's your chain rule. Right there. Plug in your x equals 4. And you just get 1/2. All right, so that is the worksheet. You can find other calculus videos on this channel done by me and other girls. And if you have any questions, you can put those in the comment section. We also have a Discord server that you can ask your own personal calculus questions or ACT questions, things like that, anything that comes up as you're doing other homework. And the link to that is in the description. If you found this video helpful, hope you did, go ahead and like and subscribe. And yeah, best of luck with your definitions of derivatives. Hope this helped.